In order to solve this question, to estimate for v prime at 15, or the derivative of v at 15, we are going to use the values in this table. Now, whenever we do an estimation of instantaneous rate of change, we're going to use our average rate of change formula. Again, just to remind us, that's f of b minus f of a over b minus a. And f could be a different letter. It could be v, it could be x. In this case, it is v, and so we want to find an interval that contains 15, but is the smallest interval. So I could do between 9 and 18 because I know 15 is between there, but I do also know that that's not the smallest possible interval. The smallest possible interval is between 12 and 18. And so I'm going to find v of 18 minus v of 12 all over 18 minus 12. V of 18 from the table, I can see, is 186. V of 12 is 201. All over 18 minus 2, that'll give me 6. 186 minus 201, that is negative 15 divided by 6. And we want to know what negative 15 divided by 6 is. Let me calculate that. That will equal negative 2.5. However, we're not done with this question just yet. We also have to make sure that we include our units. And since we are estimating, and so we can say this is approximately v prime of 15. Since we're estimating the rate of change here, we're not estimating it. We're not estimating the value of v of 15. We're estimating the value of v prime of 15. This will be negative 2.5 miles per hour per hour. Because this function was already representing a rate of change. This represented miles per hour. And then we put it over hours. And so in this case, we would write, and in this case, we write miles per hour per hour. In general, it's going to be, it's going to be whatever number we find, and then the units of f of x, or whatever our function is, per the units of x, whatever our inputs are.